Hi to everyone. Let me introduce to myself. My name is Yeşim Cengiz, and I am the PhD student in Istanbul University Cerrahpaşa Institute of Graduate Studies. I'm working with my colleagues Ayça Ergün and Eymen Konyalı. And our supervisor is Professor Hüseyin Deligöz. If you want to reach us, you can write an email to us. Our email addresses are given below on this page. Today, I'm going to give you a short presentation about controlling of the wettability behavior of multi-layer functional coatings. And the aim of the study is investigation of wettability properties and surface properties of multi-layered LBL films after passing with various ionic solvents. The ionic solvents as sodium chloride, sodium hypochlorite, ionic liquid, and PBS solution. I would like to add the definition of ionic liquids. ILs are normally defined as compounds completely composed of ions with melting points below 100 degrees Celsius. And in this work, PAH-PSS and Kitosan-PSS were selected for scanning electron microscopy analysis and contact angle measurements. We can see the device of SEM and contact angle measurement device. We use two devices on our work, actually more than two, but I want to mention of two of them. We use some polyelectrolytes. Our cationic polyelectrolytes are polyalylamine hydrochloride and ketosan. PAH includes sodium amine and hydrochloride group, and ketosan is a linear aminopolysaccharide obtained by the acetylation of chitin. Maybe you know chitin is a natural biopolymer that is abundant in the shells of shellfish and is the most abundant on Earth after cellulose. So this is the important thing to using ketosan because this is an abundant material in our nature. And our anionic polyelectrolyte is polystyrene sulfonate sodium salt, PSS, includes sulfonate group in its chemical structure. And multi-layer films were prepared by using QCMD device. So QCMD means quartz crystallization microbalance dissipation. Actually, I add the image of deep coating process to understand easily the process. Firstly, our substrate was negatively charged in ozone units in QCMD device. After that, we passed through the cationic polyelectrolyte solution on the substrate. And after that, we reached a surface with positive charge. And we used the ultra pure water to remove the unbound and weakly bonded ions from the surface. After that, again, we use anionic polyelectrolyte passed through the substrate. And then there are some negatively charged on surface. After using ultra pure water, finally, we reached the one-layered functional film. When we repeat the process 5 times, finally, we reach the 5 multi-layered functional films. Yes, we used SEM, scanning electron microscopy and contact angle analysis device to investigate the surface characterization. LBL thin films that formed on the UV glass were coated with 10 nanometer thick gold palladium layer prior to imaging. A 5 kilowatt electron bombardment was applied to the surface to take SEM photographs. and the photos were taken at 2000 and 10,000 magnification ratios. About contact angle analysis, we use the KSY attention theta device, and UV glasses with 5-layer thin films were kept in some ionic solutions as sodium chloride, sodium hypochlorite, PBS, and IL for 1 day, and then in ultra pure water for 1 day. And after that, from at least 3 points on the sample, using 5 microliter of water by pendant drop method. And let's see the contact angle results. Firstly, we investigated that the PAH-PSS and Kitosan PSS without using pass-through any solution. Contact angles were determined as 65 ±2 degree, and for Kitosan PSS, our contact angle result is 77 ±1 degree. The results show that the two surfaces are hydrophilic, but there's a little difference of them. This is because in the morphological properties of the surface. And when we look at the 2 molar sodium chloride solution as a monovalent salt, the measurements show that 64 and 62 degree of contact angle result. It means the results shows that the two surfaces are hydrophilic again, but had a lower contact angle value compared to their original state. It was thought that a certain amount of sodium chloride salt remains in the structure between the film layers, increasing the hydrophilicity of the film. And the important point, when we use the sodium hypochlorite, we saw that PAH-PSS average contact angle is almost 10. It means the surface is super hydrophilic. And for Kitosan PSS, we saw that against hydrophilic surface. So we thought that we can use this surface for easy to clean surfaces. And I want to mention that there are very low contact angle values caused by the interaction between the film and sodium hypochlorite, and the change in delta D dissipation change value accordingly. And when we use the ionic liquid, 1-ethyl 3-methyl imidazolium bromide, we saw that again hydrophilic surfaces. Both surfaces were hydrophilic, but the main reason for the significant decrease in the mean contact angle value of Kitosan PSS, it can be about the interaction between the chlorine groups in the ionic liquid and dense amine groups of Kitosan. And the last experiments with PBS, we saw that again hydrophilic surfaces. PAH-PSS showed a more hydrophilic character compared to Kitosan PSS. Due to salt retention in the structure even after washing with ultra pure water, PAH-PSS showed a more hydrophilic character. Yes, let's see the SEM results. First of all, we determined that the original state of PAH-PSS and Kitosan PSS. PAH-PSS shows us some homogeneous structure, but there are partially solid particles. But when we look at the Kitosan PSS result, we saw that agglomerated solid formations. And we think that there are insoluble polyelectrolyte complex formed because of the interaction between chitosan and PSS. And when we look at the surfaces passed through sodium chloride, we saw that relatively smooth and non-porous surfaces in 10,000 surface view. There are some smooth and non-porous surfaces. And while some granular structures originated from sodium hypochlorite on the PAH-PSS, when we look at the chitosan PSS, there is more homogeneous surface. And when we pass through the ionic liquids from the films, we saw that PAH-PSS shows homogeneous structure and there is no solid formations. But when we look at the chitosan PSS, because of the polyelectrolyte complex structure, there is interaction between chitosan and PSS, and so there are some cloudy image in here. And when we use the PBS solution, we saw there is a cloudy image for chitosan PSS, and decrease in the mass of the original film by about 10% causes this cloudy appearances. And finally, the results show that in general, it was determined that the multilayer films show hydrophilic properties. But when we use the sodium hypochlorite solution, both multilayer films showed the super hydrophilic properties. And thanks to this, we can obtain easy to clean surfaces. And it was thought that these very low contact angle values are caused by interaction between the film and sodium hypochlorite, and the change in delta D dissipation change value accordingly. Here, my references. I really thank to listen to me, and I hope to see you face to face.
You're welcome, and thank you for that nice presentation, Ms. Cengiz. Now we can have our questions. Okay, it seems that we have two questions. First one of them is, did you check the easy to clean properties of coatings you used in your study with an additional practical method?
Actually, we just measured the hydrophilicity of the surfaces, and we didn't do any experiments about the easy clean surface.
Okay, thank you. And the second question is, were there any challenging points during your study that you have to do some additional tests or some additional tests? Yeah, it was real.
Actually, we are planning to develop our study to include the easy clean species of this work, and there is no any challenge for this work.
Okay, thank you for your answers.